The name of our game is Ornery Objects. My name is Eric Bauer and Dan Haywood was my partner. The basic premise of the game is a two-player over-the-network in-browser physics-based game where you're trying to knock over your opponent's tower. This object up here is the target object. If it falls to the ground, you lose. To define each object, we have a set of static characteristics that never change from frame to frame. That's the vertices, which are relative to the center of mass of the object. We have the mass, which is basically the area. So we have an algorithm that will compute the area of any polygon. And the moment of inertia, which is the rotational mass, and that's an integration of the distance from the center and the mass. It gives a weight inertia for the rotational mass, and the dynamic characteristics which change from frame to frame is the position, which is given as the center of mass and the world coordinates. The velocity is a vector xy. The orientation, which is the rotation around the center, and that's stored as a rotational 2x2 matrix, and the angular velocity in radians per second. Collision detection first pass uses bounding circles. If the bounding circles don't cross, then it drops out. If they do intersect, it uses separating axis theorem, where it takes the normal of each surface of both objects, projects the vectors onto that surface. If they overlap, in this case you see they do, it creates this minimum translation vector to separate the two objects. After separating the objects with the minimum translation vector, we calculate the velocity at the point of impact, and that's the combination of the angular velocity of both objects and the translational velocity added together, and that's this term. To calculate the impulse uses elasticity, the normal vector of the surface at collision, the mass of the two objects, the moment of inertia of the two objects, and it uses all these values to calculate a impulse value, which is basically the severity of the collision. Next step is applying the impulse to the two objects. Object 1's starting velocity times the impulse plus the impulse times the normal of the surface over the mass of the object gives you the resulting velocity, and same for object 2, but it's a minus, and that will give an equal and opposite reaction. And similar with the angular velocities, you just adjust them due to the impulse and the moment of inertia. The following videos will show the physics engine in action.